This video will introduce you with the user interface of SENTIO, the basic operations, the dashboard, on-screen tools, wafer map, vision module, all the toolbars, basic introduction into the UI. So the first thing SENTIO starts when initiated with the dashboard. The dashboard is a graphical representation of the current system status. You can see on the screen the representation of all the different hardware components, the loading door, the wafer wallet. On the left side, you can see the chuck and the auxiliary chuck attached, as well as the chuck camera, our vertical contact environment camera. You can see the microscope cameras on the top. We also have a graphical representation of the thermal chuck interface. The current temperature system is currently turned off. That's why there's no buttons on. You can see the current position of the chuck in our graphical position monitor on the left side of the screen. On the top of the screen, we have the toolbars. The toolbars provide the most commonly used functions for each of the different steps of operation, either navigation or stepping through the wafer map. And on the right side, we have our module selector, where the user can select from different modules to operate SENTIO. Most common ones are most often used is the vision module, which is here, and also the wafer map, but also auxiliary sites for setting up calibration substrates, or Calibria to execute a calibration of the substrate and the setup. Okay, let's take a look at the vision module first. The dashboard has highlighted areas with blue color, which are actually interactive areas. So if the user selects this area, then he gets a context. SENTIO opens a menu with possible operations of this part of the screen. For instance, if I touched to the front loading door, I can move the wafer to the unload position. Or if I touch to the chuck, I can start the wafer alignment, or move the chuck to the home location, put the chuck into lift position. Or if I touch to the microscope, I can interact with the microscope and, for instance, turn off the lights. Next step I'm going to introduce is the vision module. Therefore, I activate the vision module. And we are going to take a look at here. We have our toolbars. The first one is the navigation toolbar, which allows me to bring the chuck into contact or separation position, or move the chuck to the center or the home location, for instance. The second toolbar is the stepping toolbar. We will talk more about this when we walk through the wafer map. And the third one is the automation toolbar, which is including all the functions that are required to automate the alignment of the system. On the right side of the work area, which is the video screen here, we have the side panel. The side panel includes different UIs to set up and operate the chuck for the alignment and the navigation of the wafer. So for instance, in the upper area, we have the on-screen joystick, which allows me to operate the chuck or the scope, depending on what stage is currently selected. So I can move the chuck. I have different speed zones on the joystick, so I can move it slow or first or faster. Okay, I can also bring it back to our home location at any time. Therefore, I go to the navigation tab, the chuck back to the home position. On this area, I can also set the contact position and also set the home position. It's not already defined. We have another control here on the right side of the screen to operate the Z-axis. With that, I can slowly move the chuck up and down. I can even change the speed and move more fast, or I can use the step function, which allows me to have controlled distance steps with the chuck z-axis. So I can move the chuck up in 50 micron steps, for instance, to determine the contact position. Another tab here is the subsites. Subsites are used to define individual touchdown locations within a die. It's very easy to add new subsites. For instance, if I navigate with my chuck to the next subsite location, I can simply press the add button here to add a new subsite. Let's do this. I'm going to move my chuck. Move the separation first and move the chuck to the next device a bit fast. So I'm going a little bit slower. And then add this side to our subsite table. Now the subsite again is listed on our subsite table, and I can use the buttons on the left side of the subsite table to navigate between the two subsites. So I push the first button here and it moves to my first subsite. I push the button here and it moves to the second subsite. Besides the import function, there's also export possible to memorize the subsite definitions and eventually transfer it to another machine. We have also options to enable or disable different subsites from the subsite list. And we have a filter function which allows the user to quickly find a certain subsites. For instance, if I type in something like 2 here, okay, it now reduces the list to all those subsites which include 2 in the name of the subsite list. Back to our full subsite list. Okay, you can also select individual subsites and delete them from the list, or again add new lists. You can resort using the up and down buttons and select either or none. It's also possible. The next tab here on the side panel is to define our offset values. Offset values are, for instance, the overtravel value, which is used to apply a certain contact force after the contact position is defined. So, for instance, we could enable overtravel and set the value to 30 microns in this case. Very common is also a value of 50 microns. This depends actually on the probe card or probe tip definition. You can also modify the substrate at the separation height here. For instance, if a different separation height of 300 microns should be used, then we can key this in and set the value to 300. We can also define a different hover height. Hover actually means it enables a third button which is giving us a navigation level between contact and separation. And that allows us to easily align the wafer to the probe tips. But it prevents from larger movements. So as soon as the wafer is going into the stepping function, the chuck would automatically separate. Hover is only used for the alignment of the wafer. For instance, I push hover function, chuck now moves to hover height, means it's very close to the very close distance between the wafer surface and the probe needles, and it's very easy to adjust the probe needle position. Advanced settings is a tab where the user can adjust the stepping speed or the stepping behavior. Here the user can select from whether the chuck should go to separation automatically during the stepping, or it should remain locked when it's at contact position. That means there's no automatic separation. Or the user can select whether the chuck should automatically go back into the contact position after it reached to the new die. Furthermore, we have a function called soft contact here. Soft contact can be enabled to allow soft landing of the probe tips of the chuck. If this function is enabled, the chuck reduces the acceleration when approaching the contact position. So the chuck would make a very gentle contact to the probe tips. About that, now I'm going to introduce the status panel in the lower left area of the screen. This is also very interesting. Status panel gives me feedback about the current chuck Z status. So you can see the color changes if I move the chuck up and down. Separation height means the panel would appear in red color. Red means it's not ready to measure, right? So if you move the chuck up to contact, the display turns to green. Green is the system is now ready for the measurement. If we move to hover height, it's actually yellow color. Yellow means, yeah, it's close to contact, but still not ready to measure. You can see the status of the chuck height on the left side. You can also see the coordinates of the X, Y, Z, and theta axis here. So this is the icon to visualize the current reference. Current reference for these coordinates is from home. You can also touch to the reference icon and change the reference. The next selection is a user-defined, so you could always say, okay, I want this current location to be my user-defined origin, and then SENTIO switches the coordinates of X and Y to reference from the current location. But also you can change to Z, which means it's the lower left corner of the movement area, which is now the reference, and SENTIO gives you absolute coordinates. Most commonly, we use the coordinates reference to the home location. The arrow on the right side here gives me a quick introduction or quick overview of the recently executed actions within SENTIO. So you can see what happened the last 10 steps. We moved the chuck to a certain origin, or we moved the chuck to contact or separation height. And you can also open the log file if this is desired. Closing this. Last but not least, I'd like to introduce the on-screen tools here. On the right side of the screen is a little bit transparent overlay. We see the on-screen tools. The on-screen tools give us quick access to the most frequently used functions for each of the modules. We have, first one is a menu to select from different cameras. This system is equipped with different cameras in the microscope. So we have the iMac 2 microscope here, which has a wide angle camera, which gives us the big field of view, but also a narrow camera, which zooms in a little bit more and provides a better resolution. We also have the off-axis camera system attached to the system, and also the chuck camera. And we have the VCE camera, which is our virtual control environment. Switching back to the wide camera. Next one is the light adjustment. Here we can adjust the light of the camera. I can just slide and set the light depending on my needs. The third menu is our on-screen navigation functions. We have a couple of them. The most commonly used is probably point and shoot. You can actually, when selected point and shoot, you can use the spot marker to define the target location. Moving the spot marker, for instance, to a certain tip. Then I'll touch down to the screen, and the chuck will now move to the touchdown location, the touch location to the spot marker. So if I put my needle to a different place, for instance, if I put the spot marker here, I can move another pad to exactly this location. Another function to navigate across the screen is flick and pan. So the flick and pan function allows me to track the chuck and point it to a certain area. So for instance, I can put this pad to this probe tip. The chuck will move roughly there, right? Always point to some location and move the chuck. Another function, if you don't want to navigate with the chuck, you only want to use the zoom function, then you can use your two fingers using the multi-touch function to zoom in and out into the screen image. So I can make a very big magnification here. So the zoom function allows you to zoom into the screen very easily using multi-touch capability. I just use 2 fingers. I can even use 2 fingers on 2 hands. Zoom in, and you will recognize while we're zooming in, the camera is now immediately switched as soon as we get closer to the maximum zoom level. SENTIO automatically switches to the narrow camera, and you can zoom in even further. This is really easy to operate because SENTIO automatically switches the camera between the wide field of view and the small field of view. You can also use the tap function, tap to the screen, and it will now fit the video image to the width of the image of the window, and you can tap again to bring it back to full screen. Yeah. The next function, which is really nice, is the magnification glass. This allows me to put a certain area on the screen under the magnification glass and just put a higher digital magnification onto the needle, for instance. The next part of the on-screen tools is the measurement tools. The measurement tool can be used to measure, for instance, the pad size or certain areas on the wafer. I have a function to measure the X distance, for instance. I can measure the pitch between my devices, the left side to the right side. Okay, this is about 400 microns. Can also do the same thing for Y, or I can use my XY measurement to do this together. So now I can do an X and an Y. It will show me not only the distance, but also the X and the Y coordinate of this measurement distance. The next menu enables and configures our picture-in-picture mode. You can already see our picture in the mini view in the upper left side of the screen. This is our wafer map, and it's actually a live image of the wafer map. You can configure this with the menu here in the on-screen tools to turn it off if you desire to see the full screen and don't want to see the picture-in-picture at all. The picture-in-picture in a small view enables you to quickly switch between the wafer map and the vision module, which is very nice because you often switch between these 2 modules, and it's very easy to do this using the function here. Another benefit of the picture-in-picture is that it always gives you a feedback of the current status on the other module. You can also configure this to a larger representation, so this is bigger now, or you can even select the triple view, which allows me to not only have an overlay image, you can now select 2 camera images plus the wafer map. That enables me, for instance, to select narrow camera and a smaller field of view, but higher resolution. We have the narrow camera here, which enables which gives me a high resolution image, and I could have the wide camera in parallel, which I can use for navigation. So I have 2 images, one with higher resolution and higher magnification, and then the other one which gives me the overview. Going back to the small overlay, next menu is our scope menu. We have a couple of scope functions here. The first one is the go to focus function, which brings the scope into the focus position wherever my chuck is currently located. Push the button and the scope moves to focus location. The second one is autofocus, which executes a measurement of the wafer surface and determines the contact height the focus height automatically. And we also have a function to set contact wherever my focus surface is currently located. The next button here is to enable the follow mode. Follow mode is very nice because it ensures that my focus is always maintained. As soon as I have a system equipped with a motorized Z stage, it will enable the scope to follow every chuck Z movement, maintaining focus. And last but not least, we have our QuickAlign function here, The quick alignment function is really nice if you want to do a coarse alignment, or if you just want to find a structure on a wafer and make a touchdown with any stepping. You can use this to quickly draw a line to any straight line or straight line on the screen and execute an alignment. So for instance, if I move my chuck a little bit up, maybe move it down, even better. Now enable the quick alignment tool, put the line to the horizontal line on the screen, and SENTIO would automatically start the rotation of the chuck, and I now have a quick alignment to be able to navigate across the wafer.